Okay.
Welcome, Ridwan and Dalen. It's good to have you guys back.
Welcome, welcome, everyone. Can you believe it? It is the last of 4 lessons.
I cannot. On last week, Wednesday.
Oh, is that what it was? Okay.
Thank you for reminding me. See, we've got Asonge as well. Welcome, Asonge.
Welcome, welcome. How's everyone's days going? We were just chatting before and we were saying we both had quite busy days today. Me and Elzon. How was your day? Were you productive? Were you at school? How was your day? I'm going to see James Bond tonight, so I'm pretty excited about that too. What lies ahead. Looking at the wrong part of my screen. Okay. All right. So while we're waiting, you know the deal with the do now. We'll wait a little bit longer because I think we've still got time. But what I want you guys to try and do is I want you to think what goes in this block and what goes in this block. And then, in fact, you can do these first 2 blocks. Okay, and see if you can figure out what goes in these blocks while we're waiting for everyone to join us. And if you're really on fire and you're just like graphing, this is for me, you can try the next couple, but I'm just going to ask you to do these 2 here. Okay, I'm going to carry on watching the chat stream. Welcome Ridwan and Komechlo. And who else is there? I see someone's roof. Okay. We'll just give it another minute while you guys are trying. Can you remember what a flow diagram is from the last lesson? Input, output. There we go. Hello, Nico. Dalen. How's it going? Who feels like being brave and just jumping on the audio channel there and give us a little rundown of your day? What was your day like? Good, bad, we don't mind. We just want to know you.
Hi, so my day was a bit stressful, but
stressful?
Yes, I'll try to adjust.
Okay. I'm impressed that you're here after a stressful day. That shows good diligence.
Thank you, sir.
Anyone else want to jump online? Give us a quick little, you got a nice hand clap there from Elzon. Anybody else? Tell us how your day went.
So everything went great.
Huh? You're doing great. You're winning. Okay. Well, it is really nice to hear your voices. And just to let you know, next week we are carrying on with another module on something called Pythagoras. So that is the next unit of 4 lessons. And today we're going to try and finish off in a nice way this unit on graphs. So Elzon, before I begin, is there anything else you want to say or comment or anything?
No, nothing from my side. Just enjoy the lesson and then I'll see you guys again afterwards.
Yes, totally.
Thank you.
Okay, guys, so let's get rock and rolling. In terms of what we said in the previous lesson, we spoke about basically this whole thing about graphs is about relationships, right? And so we talked about global graphs, the big graphs. We talked about coordinate pairs. And then the last lesson, we spoke about basically equivalent forms. And so the equivalent forms would be like the formula for the relationship, the flow diagram, the table, and the verbal description. And so I'm just going to do these first ones with you, and then I'll give you a little bit more chance to do the other ones. So the flow diagram for the first one is just going to be to multiply by 4. So times by 4. So whatever the x goes in by, it's going to be multiplied by 4 to give you the y. That's why in the table, if I've got an x of 7, to get the matching one in the relationship, I go 7, 14, 21, 28. And then 0.3, okay, that's a little bit sneaky, but I'm going to use my teacher powers and say 0.3 is 3.10. And if I times that by 4, I can make it 4 over 1. And so I get 12 over 10 or 1.2. And then the verbal description is to say, I simply multiply the input by 4. So that would just be how I would say it. Now, the second one, we only are given the table for the relationship. So we have to get all the information out of this table to work out what these ones over here are. So we don't know at this stage, but we know that it's a relationship. So let's look at what we've got here. To me, it looks like it's always 1 below, like 2. So one, it's always 1 below. So if something goes in as something and it comes out 1 less, I think y, I'm actually going to make my thing a bit thicker. The formula is going to be y equals whatever x is minus 1. And the flow diagram, let me zoom in. A little bit more space. So the flow diagram is just going to be an input of x. X is going to be at the beginning. And then inside, I'm just going to say take away 1, and then out will pop y. And then on this side, I'm just going to say I subtract 1 from x to get y. Okay, so that's the idea with this. But I do think that you would benefit from having a crack at these next 4. So I just want to give you, I'm going to give you a minute a question, and I want you to try and complete these because they summarize quite nicely what we've been doing. And if you think about it, in the previous lesson, we also spoke about a coordinate pair. This pair over here is just going to be the coordinate pair 2, 1. And next to it will be the coordinate pair 3, 2. And so it's important that we get this sorted out because the rest of the lesson today is going to be about how do we visualize this relationship that we're talking about. Okay, so I'm going to give you a moment or two, well, I'm going to give you a couple of moments, and then I'm going to ask you to be brave and come online on the chat and give us what you think, question 1, question 2, or question 3, and you can give us what you think. Okay, so I'll give you a bit of time. And then you're gonna jump online and let me know what to do. Or you can put it in the chat. Both are fine. But I'd really secretly like to hear your voice, if I'm honest. So if I was you, I would probably be looking at this thing here to help me figure out what's going on here. So what would the formula look like and what would the flow diagram look like? In fact, some of you might be able to type the formula into the chat. So what would the formula be? Y equals something. Pop it up in the chat there. Or you can tell me what the flow diagram looks like. I'm going to say that the flow diagram actually has 2 parts to it. So in this one over here, all you need to do is fill out that table. In this one, you just have to do that. And in this one, you have to do that and that. Aha, I see some answers coming in. Very nice, very, very nice. That's looking pretty good so far. So what we have for question 1 is we do indeed have y equals, multiply the input number by 4, then subtract 1. There's 2 ways you can write this. You can write it as x times 4 minus 1, or you can write it as 4x minus 1. And the flow diagram is simply going to be multiply, sorry guys, I need to get a thinner pen here, multiply by 4 and then take away 1. And so that would be that one taken care of. Who wants to give me the explanation for the words for number 2? Jump on the mic, quick. How do I describe this in words? What do I need to do first?
So you look at the difference between the y's. So from 7 to 11, it's 4. Then from 11 to 15, it's 4. And then from 15 to 19, it's 4. So there's a constant distance. So then
you looked at this.
Yes.
And you're saying that that told us what we need to multiply by.
Multiply the x by, then 4x, 4.
Yes.
4 times x, which is 2 for the first one. Then you minus 1 to get the 7.
That number there.
And then
Absolutely.
3 times.
Yeah, then?
Then 3 times 4 is 12 minus 1 for 11, sorry. Then 4 times 4 is 16 minus 1, 15.
Like that. You've actually pointed out something really important, that if we're looking at these tables, we should keep an eye out for if there's a constant difference, right? So even in the next one, if you look at this, like it's going up in 2s here, and that might tell us something about what we want to do going forward. So thank you so much. Who was that? I didn't actually get the name on that one.
Alwande.
Alwande, thank you so much. So I'm going to move on to number 2, and I'm going to say, look, if I look at this, the one way I could do it is I could look at the table, but the table has quite a lot of information. Probably the easiest one right here is going to be the flow diagram if I'm given the choice. And so in the words, I'm going to add 1 to the input and then multiply it by 2. And so the multiplying by 2 actually is hiding in the table. You can see it's going up in 2s there. Then for question 3, I'm simply going to follow again I can use the formula. So I go, look, this is the formula that I've got. I've got an input of -2. -2 times 2 is -4. Plus 2 is -2. Got to watch out for my negatives and positives here. -1 times 2 is -2, plus 2 is 0. 0 times 2 is 0, plus 2 is like that. And it's going on like that. So that's what the table should look like. And in this last one, I should multiply the input number by 2. So I'm going to multiply it by 2 and then add 1. And then to get my formula, I suppose I could just double -2, which is -4, and add 1 is -3. -1 doubled is -2, add 1 is -1. And you start to see this pattern actually, that when you multiply something by a certain number, it seems like it goes up in that step size over here. Like I can always predict that that's going to be 1 and that's going to be 3 before I even did it. Let's just check. 0 times 2 is 0 and then 1. So in our patterns, there's something called a constant difference. And as long as we're going up in a unit of 1, it seems like in a lot of these questions, the y goes up by a certain amount, and that certain amount is what we're multiplying by. Now, that's a bit of a mouthful. You don't have to know every last detail, but it's something just to keep an eye out for because it will repeat. And the main reason I wanted to show you this question was just because I wanted to show you that this is all the same relationship. And so now we're going to move to showing, well, What if we want to see this relationship graphically expressed in a graph, which is obviously what this unit is about. But well done, everyone. That was really good. As we look back on this course, you can see what we've done already. And today we're focusing on drawing graphs. And before we do that, I just want to see if you can do this multiple choice question for me. So everyone at home, everyone online, do you think these points come from the relationship A or the relationship B? And I want you to look at this question. It says, which rule, we even look at the wording, which rule describes the relationship between X and Y coordinates on the following graph? Another way of saying this is, which rule describes the relationship between the input and the output? And there are many relationships hiding in these points. And I want us to see if you can work out which of the global relationships, so which of the formulas match this graph. It's either going to be A or B, and I want you to lock in your vote. If you're watching on the website, if you're watching at home, I want to know. And I actually am not that worried if you get it wrong or right. I just want you to make a choice, and then we will discuss. Okay. Okay, good. I see some answers coming out. I like it. I like it. I mean, I suppose if I wanted to understand what this is saying, is the first one, if I was drawing a flow diagram, I suppose if X goes in, if X is the same as Y, I'm just timesing it by 1. Whereas the second one, if X goes in, okay, it's a little bit more complicated because it's the way it's hidden, but there's more going on in the second one. But at the moment, it's not easy to tell exactly what's going on. So let's look at this point. That point is going to be the point 2, 2, or the coordinate pair 2, 2, where that is X and that is Y. Now, what's this point going to be? Well, it's going to be 5, 5. And what's this point going to be? Now, there's something about this relationship that stands out to me. What do you notice in all the XY pairs in a word? What do you notice when you compare X and Y? You can shout it out or you can put it in the chat. Don't you notice the X and Y are the same for those points? So for me, it looks like, and if I look at the formulas, there's only one formula that has the X and Y being the same. It's A, whereas B doesn't have that relationship. So let's even check. If I put X into this formula, if X is 2, Y must be 2. If X is 5, Y must be 5. So we can see this formula is telling the story of this graph. Whereas if I try B, if I put X is 2 into that, let's have a look. X is 2, I get out 2. If X is 5, okay. If X is 5, I would go 5, sorry. I'd go 2 times by 5 minus 2, which gives me 10 minus 2, which gives me 8. Is there any point 5, 8 on this graph? No. You can see this graph goes like this, and the point 5, 8 is here. So I hope you're making the connection between the little relationship, as I call them, the coordinate pair, and the global relationship, and matching the two, because they have to tie up. Okay, let's do another one like that. It feels like that would be good. So I'm going to jump to here. I've got one of these matching graphs to formulas thing here. I'll zoom in for you in a second. Let me take this one. Sorry if you're getting dizzy. I don't want that one. No, I actually want this one. Okay. Let's do this one. So there are 3 choices here. It says match the equation, or the equation is just a way of defining the relationship. Match the equation to the coordinates on the graph. And the equation we're given is y equals 2x plus 1. Okay, that's the way we're describing it. I want you to see, can you match? Do you think A matches? Do you think B matches? Or do you think C matches? So take a moment, use the technique I used in the last lesson, I mean, not the last lesson, the last question, and see if you can figure out which of these three matches that. And I'm actually going to give you a moment because this is a really good question. And I want you to think, what did I do last time? Didn't I investigate these little mini relationships? Because essentially, like, these points form a graph if you draw a line through them. But they're telling you a little story, and you need to connect the little story to the big story up here. And while you do that, I'm going to get some water. And then when I come back, you're going to either tell me A, B, or C. I'll help you get started a little bit. What's the coordinates of this point over here? So it looks like it's in line with 6 over here and 1 over here. Oh, wait, let's make sure I'm doing the right thing here. Okay, maybe the drawing is a little bit out. Maybe that's causing a bit of confusion. Is that a 2, 4, 6? 4, 2, 3, 4. Okay, so this point over here would be 4, 6. That point there, to me, looks like 8, 8. And this point here looks to me like 10, 9. Okay, 4, if I double that. Over here, this point, oh, this is very confusing. Okay, you know what? I think the scale on this question is actually not that great. And so I was trying to get you, this is what I was trying to get you to do, but I'm going to move on because I think the scale is too wonky to be helpful. I wanted you to get the coordinate pairs, write them out, and then try and figure out which ones match that 2x plus 1 over there. Okay, so that was my intention, but I'm going to move on because the scale, I think, is just a little bit wonky. Okay, we've done that already. We've done that. Let's actually go to drawing a graph. How do we actually draw a graph from a table? Let's do that. Okay, I'm going to define the relationship y equals 2x. And I'm going to teach you how you actually draw a continuous graph on the Cartesian plane. You'll notice that my Cartesian plane is here, but what I'm first going to do is I'm going to get points that go onto that basically represent the relationship. And so I'm going to have an x and a y. And what I'm going to do is I'm going to put some values. So let's say like -2, -1, 0, 1, and 2. And then what I'm going to do is I'm going to use this formula to help me work out the matching y. And the y is the output. So I'm using the word input, and output, I'm often using x and y. So if my input is -2 and I double it, I get -4. If I input is -1 and I times it by 2, I get -2. And I get that. Now this gives me 5 mini relationships or coordinate pairs. So the first one, I go to -2 on the x-axis. and then I'm going to go down to -4 on the y-axis. So my very first point is going to be over here. That's this one, -2, -4. I'm just going to do this one first, and then you're going to do it one for me afterwards. The next one is -1, -2. So I go across by 1, and I go down by 2, and I get my next point. The point 0, 0, it's got its fancy name. Does anybody know what the fancy name for the point 0, 0 is? I'm just going to watch the chat for a moment. What's the fancy word for the point 0, 0? Starts with an O. It's called the origin.
Origin. Yeah.
Yes, I heard it. Well done. Well done. It sounds all fancy, doesn't it? Like the beginning of time or something. Okay, next point. Inputs 1, outputs 2. So you get the point there. And then the next one is, so we've done these guys. 2 across, 4 up. So we get that. Now, what you notice is that this relationship of y equals 2x, when you plot its points, you will notice that I'm getting a straight line relationship. And when we draw that straight line relationship to show that we could carry on adding more x values and y arrows forever, we put arrows on our line and we label the equation of this line on the Cartesian plane. And so this is graphically representing the relationship y equals 2x. And so this is the process. You basically just draw up a table, you get your mini relationships, you put them on the Cartesian plane, and then you link them to draw the graph. And this is called a continuous graph because it can continue forever, and all the values in between are defined, as opposed to a discrete graph where only the values on like the 1, the 2, the 3 are defined. So it's time for you to draw for me a graph, and you're going to do exactly what I did, except it's going to change slightly. Your graph is going to be y equals 3x. That's the relationship. I want you to start by setting up a table. I want you to then complete the table, and then I want you to try and plot the points and complete the graph. Okay. And I'm going to give you 2 minutes to do that. And then I will show you what the graph looks like, and we'll see if we agree. What you can do is you could use any points, but often we start with a couple of negative ones and a couple of positives. And so a good way to start is just to do basically those ones as your inputs. But you could use whatever input you like, because whatever input you use, you're always going to have to use the 3 to work out the output. But in textbooks, you often see we go like this. I'm interested to know if your graph is steeper or is it shallower than my original graph? You know, if you were climbing up a graph, would you want to climb up my one, or would you want to climb up the one you're drawing now? It's an interesting question to ask yourself. Which one is steeper when you draw it?
Sorry, sir, are you asking which graph is easier to draw, or?
Oh, no. So I'm asking you, when you draw it, I'm assuming when you get it drawn here now, maybe it looks like that, or maybe it looks like this. I'm not sure. Which of the two, or if you're comparing it to the original one, which graph would be steeper? Or like if you were climbing it like it was a mountain, it may be a way to describe it. Does that make sense?
Yes, sir.
I'm just kind of, throwing it out there because there's something that we're going to talk about a little bit later, which involves that idea. So I'm just kind of throwing it out. Let's see, we get I think that's what I get. So now I've got these coordinate pairs. Now I'm not going to draw them out every time, but I'm just going to show you some of them. These are the little relationships that make up the big relationship. So 1, 2. So I think that's my first point. -1, -3 is there. Is that right? Might be -1, -3, yes. And I get that. 3 up, 2 and 6. So when I draw this relationship, that is the graph that I get. And I have my 5 mini relationships that are making it. So do we think that the second one is, do we think the second one is steeper, or do we think the second one is shallower? If we have to look at the 2 graphs. What do you think? So I think that in the first one, even though it's quite steep, the second one is even steeper. And in the terminology of graphing, we say the gradient of the second one is 3, and the gradient of the first one I did is 2. So basically, if I go across by 1, I have to go up by 3 in this second graph. Whereas in the first one, if I went across by 1, I only went up by 2. And so we say that the gradient is steeper on the second one, and that is because of the 3. The 3 in my formula makes the graph rise up quicker. Okay. Are there any questions or comments? Can we do another one? Give me a thumbs up if you want to do another one, and give me a thumbs down if you want to move on to practice this. So thumbs up if you want to practice another one, thumbs down if you want to move on. I'll just give you a moment there. Okay, so Anke is ready to move on. Anybody else? Thumbs down, thumbs up. Both are equally valid. We could do one more if there's a demand, but if there's lots of people who... Okay. So I'm going to move on then. What I'm going to ask you to do is I'm going to give you a old exam question. Let's have a quick look. Let's look at this together. Okay, so this is from an old grade 8 exam that we wrote at a previous school of mine. And I just want to show you the bits and pieces, and then I will show you the, you can do it by yourself. So part 1 is a story. And the story is about this picture over here with matches. And this picture 1 has a certain number of matches. Picture 1 has 4 matches. And you'll see that that is shown in this table here. Now, what is a little bit different is instead of using X and Y, they're using N and M. But that's just because of the number of the picture and M for matches. So the input and output doesn't have to be X and Y. It could be whatever you want it to be. It's just traditionally that. Now, what you want to do is you want to work out, if you can, first of all, to fill in the missing values here, or it says you find the values of A, B, and C. And then it says write out a rule or a formula to describe this pattern. And then it says if CPOR has 454 matches, how many squares can you form? So that's a little bit tricky, but can you try and find, I'd like you to try and do these two for me first. And then those who are really feeling strong, try and do the next one. But can you figure out what A, B, and C is? And then I'd like you to write it in the chat for me. So what is A? What is B going to be? And then what is C going to be? So, and even just to help you, what's happening here? I have 4 squares here, and I still have 4 squares here. But then what I do is I add something extra on. And then for the next one, I have that. And then I have that. So we want to know what is A, what is B, what is C, and that's for 3 marks. And then we're going to try and work out a rule where the input is going to be N. You can have a flow diagram if you like, and the output is going to be M, or we can have a formula where we write M equals something N. We're going to use the ideas we've been talking about so far. Okay, I see answers coming in. That's fantastic. I'll give you a bit more time to also have a crack at the formula. Something else that was interesting, we mentioned this earlier in the lesson, but you can see that it seems to be going up in 3s here, what we call the constant difference. So that might be helpful when we're trying to build our formula. Now, if this is 5, what do we think A is going to be following that pattern? Okay. Okay, I see some interesting values coming in. Fantastic. Keep them coming. And then what do you think the formula is? In words, another thing we can do is we can also say in words what's happening. And it feels like in words, it's saying, look, we start with 4, and then each time we add on 3 matches. That's how I would describe this pattern. If I look at it visually, I'm just adding on 3 each time. So remember before we did it with words, this pattern feels like it's 4 plus 3 plus 3 and so on. So that might be helpful as well. Okay, I would say that A is going to be 16 because you can see from the formula that it's following. To get to the next one, I simply add on 3 to the previous one. Now, where it gets a little bit sneaky is that in the next value, it suddenly jumps to 31, which means that the jump from here to here is not going to be 6, right? You could see what 6 is going to be, and it's not going to be that. So this is where it might be helpful to think about what formula kind of would get me there. And part of me wants to say, look, I suppose part of me wants to go to like formula land and say, look, I know that when I started it, I had 4. And then I seem to times by 3 times n, and that gets me to 31. So let me just take a moment and see if you understand why I'm doing this. 4 was what I started with, okay? That was the 4 over here. I know that I add 3 each time that I do this. And I'm really interested in knowing when the output is 31. So if I use the idea of an equation, okay, let's just see if this works. If I use the idea of an equation, if I take away 4 from both sides, would you agree with me that I get 3n is 27? And then if I use the rule of an equation, which says if I do the same thing to both sides, I divide by 3, then n would be 9. Now let's see if that makes sense. If I start with 4, and then I add that plus 3 times 9, I do get 31. And so for me, this is going to have to be 9. Does that make sense? And then for C, if I'm starting at 100 in this formula, it feels to me like I should say, in fact, before we even figure that out, let's build the formula. So let's build the formula. Let's see if we can do this. If I'm trying to relate n and m, I know that I'm always going to start with 4. And then I'm going to times it by 3 times the number of the picture. Let's see if that works. Does that work? No, it doesn't fit. Because if I put 1 in, I'm going to get 7. So what I actually need to do is I need to adjust this down and make this 1 plus 3n. Now, some of you are probably feeling a bit like, what's going on here? And I think the easiest way to think about this is, think of it as a balancing. If this is going up by 3s, I know that I need to have a 3 times my input. Okay, so if I go 3 times my input, 3 times 1. Now, 3 times 1 is not equal to 4. So what do I need to add to 3 to get to 4? I need to add 1. And so my formula is just going to be 3 times the input plus 1. Let's see if that works. 3 times by 3 is 9, plus 1 gives me 10. Okay, so that's this one over here. 4 times 3 is 12, plus 1 is 13. So I think the moral of the story is when we're working out the formula, it's good to look at what we call the constant difference and find that. When we find that, we multiply the input by that number, and then we look to balance it by adding something. And in this case, we added 1. So to come back to this question, if I take 100 and I times it by 3, I get 300, and then plus 1 is 301. Okay. I can feel like I've probably lost a lot of you on that one. So I will, let's do another question where I actually just focus on that particular thing, just so I don't frighten any of you too much. Okay. So I'm going to give you a pattern here. And this pattern is going to go 1, 2, 3, 4. And then over here, it's going to be 4, 7, 10, 13. So this is a relationship between inputs and outputs. Now, I want us to build a formula for this relationship using the idea that looked a bit strange in the last question. Now, what I said was that we would look at how much it's going up by each time. And in this case, it's going up in 3s. It's clearly going up in 3s. So if this is my x and my y, the way we're going to do this is we're going to say y equals 3x. But that's not correct, because if I take 1 and I times it by 3, I get 3, not the 4 that I want. So what I need to do is I need to add 1 to it. Okay? So here's what you're going to do for me. You're going to try and give me the formula for this relationship. So again, I'm going to give you 1, 2, 3, 4, and we're going to start at 2, 6, 10, 14. I want you to write in the formula into the chat that describes this relationship. And if I see that most of you are getting that correct, then I will go back to the question, because I just want to make sure I haven't given you a fright with that hard example. Okay, I see add 4s. So it's going up in 4s, yes. That is a good first place to start. But now I need to get the actual formula. Oh, I see some things coming in. Nice, let's keep it coming. Who agrees with Alwandes? Or do you have something different? So according to what we did before, because we're going up by 4s, we're going to get 4x. But now my first number isn't, if I put 1 in as an input and I times it by 4, I get 4. And that's not what I've got here. I've got 2. So what I need to do is I need to modify it and I need to take away 2. And let's just see if this works. So 2 times by 4 is 8. 8 minus 2 is 6. Okay, so this does work. Let's do one more like this. If I give you this, what is the formula that describes this relationship? So that's 1, 2, 3, 4, and this is 7, 12, 17, 22. I'll wait for the answers in the chat. What's the first step? What am I going to do over here? How much is this number going up by? Oh, there we go. See some things rolling in there. I definitely see this going up in 5s. So it's almost like this graph is growing in 5s, or like what I said before, it has a gradient of 5. You know, it's going up. If it goes across by 1, it goes up by 5. But that alone does not give us the formula. So if I say input of 1 and I times it by 5, I do not get 7. But if I add 2, then I'm going to get it. So my relationship is defined by the input times 5 plus 2, or in maths language, y equals 5x plus 2. Okay, the last thing we're going to do now is we're going to draw this graph. So I'm going to bring across a Cartesian plane. And so let me quickly grab one from the side here. And this will be our last thing of the day. So, in fact, I need a bigger one, don't I? Because the numbers are quite big. Let's go to this. Or maybe let's be easier. Okay, let's just do it on this one. Okay, so if I'm going to plot this particular graph and I want to get a visual representation of it, let's finish off with that. So all I'm going to do is I'm going to go, where is the point 1, 7? I go 1 across and I go 7 up. So that would be that point there. Now the point 2, 12 is actually going to be off my graph. So you know what? It's probably going to be up here. But I'm going to be clever. I know that this relationship holds no matter what input I have. So instead of having a 1 there, I'm going to have a 0. What do you think is going to be the y value that goes with when x is 0? Put it in the chat. You've got your rule over here. If my x is 0, what does my y value have to be that goes with it? So if I put in an input of 0, what's the y value that goes with that? Any ideas? How could I use this formula over here? Aha, nice. Well, 5 times 0 is nothing. And so the only thing I've got is 2. And so you're quite right, 0, 2. Now, if I'm actually plotting a straight line graph like this, I only actually need 2 points. And so the graph, I know it's not perfect, is going to look like that. Can you see how steep the graph is? If I go 1 unit across, I have to go 5 units up. And I just want to end with this as an introduction to sort of what you'll do in grade 9 graphing. The special name for where a graph cuts the axis is called the intercept. And so this over here is called the y-intercept because the graph intercepts the y-axis at that point. Where it cuts the x-axis is called the x-intercept. And you'll talk a lot more about that in grade 9. Okay, so I'm going to bring this series to a close at this point. I'm going to allow maybe a little bit of questions and then hand back to Alzan. But the main idea of today was to realize, look, there's different ways of explaining relationships. And when we need to represent it graphically, all we need to do is take these mini relationships, put them on the Cartesian plane, and then if we link them up, we see that shape. And that process, we can go backwards and forwards between the graph, between the table, between the flow diagram. They're all just different ways of showing relationships. Okay. Are there any questions or comments that you'd like to make? We've still got a bit of time. Is there anything you want to ask or clarify? I have one little sneaky thing I can show you, and then I'm gonna finish off. Any questions or anything you'd like me to do again? If we look back over our journey today, you can see it all here. I do have an exit ticket for you as well that you can practice after this. That kind of summarizes the whole section. Okay, before we go to that, I just wanted to show you that real life graphs do actually happen all the time. So this was, I went onto my Fitbit scale here, and I wanted to show you that, this is what, when I weigh myself every so often, you can see that this is a graph showing my weight from 2018 to 2021. You can see how I went up for quite a long time over here. And this is because I was overseas and I was eating unhealthily. And then you can gradually see how this year, I've been kind of eating more healthily and coming down, although I had my birthday recently, and I think that's why it's going up again. So graphs tell us a story. They tell us a story about two things. In this case, this is my weight over here, and this is time on the axis. And then if you look at your cell phone usage, this is also another good graph to look at. So, it's a good idea to keep an eye on how much you use your phone every day. And so that is my iPhone's keeping track and how many times I picked up my phone in one day. And most of that is WhatsApp. So I just wanted to end off with this idea that graphs, it's important to understand graphs because a lot of the world's information is presented in graphs. And then if I could just end by saying thank you very much. I have enjoyed teaching you, and I'd like you to just quickly take these quiz codes down so that you can practice these after. They give you kind of a summary of the stuff that we've been doing. And yeah, Alzan, back to you. Thank you very much for your help. And I think we are going to wrap things up.
Awesome. Thank you so much, Peter. Before you hand over to me, is there anything you'd
Yes.
like to say about next week's classes and the next topic?
Okay. So like I said, the next topic is more geometry related, and it's going to be a lot to do with triangles. So there's a famous theorem called the theorem of Pythagoras, which people have known about since the ancient Egyptians. And it's a particularly useful thing in geometry. And so what we're going to do in that is we're going to explore some of the places it's used and just learn how to apply the theorem consistently, because it's very helpful in later mathematics. It comes in a lot. And so our plan is to just explore what does it actually even say and how do we use it. And it'll also be a 4-lesson course, and it's guaranteed marks in the bag once you understand it, right till matric. So that's a preview for next week. And yeah, it should be lots of fun.
I'm sold. You'll see me there, definitely.
So,
Thank you, Peter, for explaining. And then, guys, congratulations. You guys have completed the series, this 4-time series on graphs. And although we are finished, we're not yet finished. There's always some extra work to be done with regards to practicing, hey? So before I go on to sharing my screen, I just love to see some emojis on how you're feeling about this topic. You can either share in the chat or you can share a reaction.
totally.
Okay, we've got an excited face from Alwande. Welcome, Alwande. I believe this is your first time. Another excited face from Kamogelo. Nico.
I'm interested to know also, what was one favorite thing and one thing they would improve? So one favorite thing and one thing that they would improve. If they're brave enough to put that in the chat, that would be awesome too. So one thing you liked, one thing you think could improve, or you'd like, something like that.
That's a good question.
So I've got a moment for that.
So how about maybe unmuting yourself, sharing with us?
There we go.
What was your favorite thing if you had to choose between these 4 lessons?
Okay, flow diagram. Totally. And what would be one thing you would change? Actually, I think they get a form afterwards or something like that too. So I won't take too much time. It's always just helpful to get a sense of what.
Of course. Well, guys, congratulations. You finished, and therefore you get this Nobel Prize of seeing this cute dinosaur. So this is for all of you guys. Well done. Give yourselves a hand clap. And like I said, we're not finished yet. There's some revision work still to be done. But before we go on, here's the leaderboard.
Well done.
So I've got the leaderboard from Watobe. We've got, I put Pumuzile in twice here. So Pumuzile and Ridwan is actually in first place with 5 lessons done, and Adriel is in second place, and then Peter, you were in third place with 3 lessons done.
Oh, is that me?
That was you.
It's when I was looking at them to get the questions. So some of the questions I took from the app, and I must have done a few things.
Well done for you. Congratulations for making it as well. And then something else that Peter said that we'll show you guys is the score on the Join My Quiz. So basically, we've got Gemma and Amashle in first place with 9. Is it activities, lessons?
It's basically a score for the quiz that they took. So Yeah, so that was just, I think, yeah. So just to show you that your hard work in doing the exit tickets I do see it, and it will help you, yeah.
Yes. So well done to Gemma, Amashle, Asonge, Lutando, Twanelo, Gershom, and I believe that's Nokubonga and Ayabonga.
Yeah.
So
well done, guys.
Keep up the good work. And then for the last revision work on graphs, if you haven't yet gone into the app, you can just go into the app and search for the topic graphs. Then underneath the subtopic graphs from tables, you'll find the quiz right underneath. But make sure that you know all of these topics above as well. If you haven't tried them out, try them out and then test yourself by doing the quiz.
Yeah. No, that'll be very good fun. Yeah.
Yes, yes. Well, that's it from us. We hopefully will see you again. Yes.
Yeah, you can go.
Sorry, sir. I wanted to ask, how do you join join my quiz?
Join my quiz. So all that you do is you go to the, let me share my screen for a second before I go, because once you get this, it's really easy. So you go joinmyquiz.com and it pops up. Can you see my screen, Alzon? Are you seeing the quizzes?
Yes, I can see your screen,
Yeah,
Peter.
sure.
And then you get the code 4355. So in this case, this is the quiz that and then it takes you straight to the quiz. And if you start, so it says, where is point A located? And you find point A, it's at 27. Woo! I'm winning at luck. Okay, so I won't spoil the fun, but yeah, that's where you go.
Awesome. Okay, guys. Well, take care. Thank you for the questions, and we look forward to seeing you again next week, Monday.
Brilliant. Thanks, Alzon. I'll see you
Thanks,
soon.
Peter. Bye-bye.
Bye.
Thank you, sir.
Good.
It looks actually exciting.
Yeah. Yeah, no, it is. I promise you, it is such a good, I've had so many students who love that tool. So give it a full go. It will really help.
All right.
Okay,
thank you,
cheers,
sir.
everyone. Bye.